All right, so we are going to start 2.1 today. This is a long one, right? There's 19 slides. We'll finish it tomorrow after your second portion of your test. 2.1 is quadratic functions. So when we talked about transformations and mentioned that we're going to spend a lot more time diving a little bit deeper into the parabolas, this is that, okay? So these graphs, we can use transformations to help us with them if it's in standard form, but then eventually we're going to have to dig a little deeper and find more information about these graphs to make them more accurate, okay? This, again, should be total review. If you were in Algebra 1 Honors, it started at the end of there, and you saw it again in Algebra 2, and then obviously now, if you were in Algebra 1 Regular, you may not have seen quadratic that year, but you definitely saw it last year. So hopefully this is a bit of a review. Quadratic functions. So this is a function in quadratic form. F of x equals ax squared plus bx plus c. The graph is called a parabola. It's shaped like a U, and it's symmetric to the line we call the axis of symmetry. Sometimes that is the y-axis, sometimes it is not. And we will learn how to find it. So graphs of quadratic functions, again, parabolas. The one on the left is a parabola that is facing downward. The one on the right is facing upward. If it faces down, it has a max. If it faces up, it has a min. These are absolute, so there's only one of these. The axis of symmetry is the vertical line that runs through the vertex, which is the point in which your graph changes direction. Changes from increasing to decreasing or decreasing to increasing. So eventually you're going to be able to tell me all sorts of information about these parabolas. Domain and range, max or min, axis of symmetry, vertex, intercepts, and when in doubt, plot points. So I'm going to say back and forth a lot of times today, quadratic form, which is this, where you have an x squared and an x, and then standard form, which is what we're going to look at in a minute, where you just have a single x. It's usually in parentheses squared, okay, which is what we were doing transformations with. So there's two different forms of quadratic functions, standard and quadratic. Quadratic is the one that has an x squared and an x. Standard will just have a single solitary x. If a is greater than 0, think about what would be on the front of something if we did transformations, then this parabola opens upward. If it is less than 0, then the parabola opens downward. Consistent with what we talked about for transformations, right? If the number all the way at the front had a positive sign, then it would be your standard parent function. If it was a negative sign, it reflects it over the x-axis and it would point it upside down. All right, so let's start from the basics. It says graph the parabola by plotting points. This is in standard form, so you already should have some like tools in your belt that can help you with this. What do I know about this graph? It's narrower than normal. It's to the left one. Which direction is it pointing? Up. So we can kind of approximate where this is going. Left one. Pointing up and narrower than normal. So that's what it should be at the end, something like that. However, this is no longer exact enough. We're going to plug in additional points, okay? My recommendation is plug in points related to your vertex. So put the vertex in the middle. So if I'm going to plot 5 points, so we can get an idea. 1, 2, 3, 4, 5 points. I'm going to put the vertex in the middle. So this was -1, and it would have been -1, 0. That would have been my vertex. And then I'm going to plug in points to the left of that, like -2 and -3, and plug in the points to the right of that, like 0 and 1. And plug them in. So if it's -3, 2 times -3 plus 1 squared is 2 times -2 squared. I square first and then multiply by 2, which means this is 2 times 4, or 8. And then I go to the next one. 2, -2. Plus 1 squared, 2 times -1 squared, 2 times 1, which is 2. Go to the next one, 2, 0 plus 1 squared, 2 times 1 squared, which is 2 times 1. or 2. And the last one, 2, 1 plus 1 squared. 2 times 2 squared is 2 times 4, which is 8. So what's happening with my points to the right and the left of my vertex? They're the same. If you put your vertex in the middle and you go in the same increments to the right and to the left, like I can't go up 1.5 to the right and 1 to the left. It has to be the same increments, but they should reflect over that axis, okay? I would say if this is a quiz or a test, I'm going to plug in those individual points. If you're doing homework and you want to just rely upon the fact that you got those points to the left, right, so you can reflect them over the right, that's one thing. But if you make a mistake on one of the points to the left, now you're reflecting it wrong over the right. So be really careful. So now I'm going to plot these points. So negative 3, 8. Say this is 8 up here. Negative 2, 2. Negative 1, 0. 0, 2. And 1, 8. So we were pretty close in our approximation, okay? But this time, now we're moving on. We want to make sure that these are exact. You need at least 3 points, including your vertex. They need to be 1 in the middle, like you need to have your vertex, and you need to have at least 1 on the right and 1 on the left. Questions so far? All right. If it's in standard form, like that one just was, then we can pull information out of it without even doing the transformations. So you can take this and you could, like draw yourself a little picture and say, okay, that means that that's right and up or left and down, whatever it is to find your vertex. Or you take the opposite of what follows x, and that's your h, and you take what's after it separated by the plus, and that's your k. So if you look, so the last one was 2x plus 1 squared, okay? So the opposite of what follows the x here, the negative 1, is the x coordinate of my vertex, and then whatever's added or subtracted to here, which technically is a 0 this time, that's the y coordinate of my vertex. So that's how I can pull it out of the equation without even drawing a picture. And then the line of symmetry comes from x equals h. So my line of symmetry is a vertical line, which means it's always x equals, and it's always the h, which is the first coordinate of your vertex. So the line of symmetry from that last graph would have been x equals negative 1.
Wait, so hk is x1?
Correct.
Okay.
xy of your vertex. Yeah. Okay, to graph using the standard form. So we're going to determine first if the parabola opens upward or downward. Then we're going to find the vertex. And then it's usually going to ask you for your intercepts, so you might as well find those. Review, x-intercept, you're plugging 0 in for y. Y-intercept, you're plugging 0 in for x. And then you're going to plot the intercepts, you're going to plot the vertex, and if that's not enough information, you're going to plug in additional points. Some to the left of the vertex, some to the right of the vertex. All right, so we're going to walk through one together, and then you're going to do the next by yourself. So this says f of x equals negative x plus 2 squared plus 4. So which direction is this facing? This is opening downward, okay, which means that when I draw my graph, I should see it follow that curve. What's the vertex here? Negative 2, 4. What's my axis of symmetry? X equals negative 2. If you forget that x equals, it is no longer a line. It is a point. You have to have the x equals. Okay, now let's say I want to start with my y-intercepts, because those are the easy ones. I would get y equals negative 0 plus 2 squared plus 4. Negative 2 squared plus 4. Negative 4 plus 4, which is 0. So 0, 0 is my y-intercept, which means what else? If it's 0, 0, it's the y-intercept and what? The x-intercept, but there could be more than one. So x-intercepts, I'm expecting the 0, 0, but there could be another one. So 0 equals negative x plus 2 squared plus 4. And then I gotta solve. So subtract the 4. I gotta get rid of the negative on the front so you can divide or multiply by negative 1. I got to square root both sides. What happens on the left? What happens if you square root to solve? Plus or minus. So this means x plus 2 not only equals a negative 2, but it also equals a positive 2. So x equals negative 4 and x equals 0, which is where that other point came from. And now I'm going to plot all that information. So negative 2, 4, which is my vertex. 0, 0 is my y and one of my x-intercepts. And then negative 4 is the other one. I already have 3 points in which I could connect. Gives me my parabola. It faces downward like it's supposed to. If I based it off transformations, it would have been left 2, up 4, pointed down, which is consistent with what I've got. And my axis of symmetry is x equals negative 4. I'm sorry, negative 2. If I fold the graph along that axis, it should overlap. Is this an even function? No. It's symmetric, but it's only symmetric to the x-axis. I mean, to the axis of symmetry. Does that make sense? Okay. Even has to be symmetric to what? The y-axis. All right, vertex should have been 3, negative 4. Your axis symmetry is x equals 3. Your y-intercept, it would have been 0, 5. Your x-intercept, 1, 0, and 5, 0. And then graph it, and it should look something like that. Raise your hand if you got it right. Good. All right. What happens if it's not in standard form? So there's 2 options. The first is force it into standard form by completing the square. So if you get an equation that has an x squared and an x, and you want to put it into into standard form so we can do what we just did, then you're going to complete the square, okay? So if you remember completing the square, you're taking something that is not already a perfect square trinomial, you're forcing it to be it, okay? You factor it, and then you get it into standard form. This is one option. You're going to be forced to do complete the square, and then I'm going to show you how to do the other option, so make sure you know how to do both. But if I just gave you a graph that said graph it, and it wasn't in standard form, you kind of have the choice. You want to do whatever makes sense the most for you, okay? So how many of you remember completing the square? Okay, so we're going to review it, okay? All of you have done it, and hopefully when I start to go through the steps, it looks familiar, okay? But it's definitely a skill you need to know how to do. So the first thing you end up doing is grouping the first 2 terms together. So I do something like ax squared plus bx. I'm going to leave this space, and I'm going to bump the c to the outside. And my goal here is to plug in a value in this space so that what happens inside that parentheses is a perfect square trinomial. If a is not 1, so if it's a negative or if there's a number there, then I have to take that a out. When I take it out, I'm dividing both the ax squared term and the bx squared term by it, okay, which we'll walk through these steps. And then I take the middle term, which is b. So to add in here, I take b, I divide it by 2, and I square it. And that's what I add inside the parentheses, and I will subtract outside the parentheses because I have to balance this equation. And then you're going to factor your perfect square trinomial, and your function should be in standard form. F of x equals a times x minus h squared plus k. So again, we're going to walk through these steps for this one. So example 4 says, write the function in standard form, identify the vertex, the axis symmetry, and the x-intercepts, and then graph it. So this is not in standard form, right? If it's got an x squared and an x, it's not in standard form. So what's my first step for completing the square? I'm going to group these two terms together, right? So x squared minus 14x. I'm going to leave this space, and I'm going to bump the 54 to the outside. If there was something in front of the x squared other than 1, I would factor it out. There's not at this point. We're going to baby step our way into that, right? There's not at that point, so I would leave it the way it is. So then I got to figure out what goes here. I take this 14. I ignore the sign because I'm going to end up squaring it anyway, so it does not matter. I'm going to do 14 divided by 2, and then I'm going to square it. So what's 14 divided by 2? 7, and 7 squared is? 49. That is what I add inside the parentheses and subtract outside the parentheses because I've got to balance this equation. I can't just change one part of it. So I've got f of x equals x squared minus 14x plus 49, and then 54 minus 49, which is a positive 5. With me so far? All right, so what I just did was make this a perfect square trinomial. When I factor it, so I get f of x equals, I can factor it this way, x and x, and then what are the factors of positive 49 that sum to negative 14? Negative 7 and negative 7, right? Because they have to be negative for the middle term to be negative. Which becomes f of x equals x minus 7 squared plus 5. So I can do it the way I just did it, or there's a shortcut. Once it's in a perfect square trinomial, which is the whole goal there, then to factor it, I do the square root of the first term, the square root of the last term. I take the sign from the middle, put it in the parentheses, and square it. So a shortcut that will make your life a little bit easier, okay? But you can get to it the long way too. It's just that you have to eventually write it as something plus or minus something squared. So it has to be in this format. This is standard form. With me so far? Yeah? Okay, so now I'm basically starting my example like I did from the last one. This is my equation. What would be my vertex? Positive 7, positive 5. What's my axis of symmetry? X equals 7. And then I would do my x-intercepts. 0 equals x minus 7 squared plus 5. Subtract the 5. What happens when I go to square root that 5? Negative 5. Can you graph an imaginary number? No. So that means there's no x-intercepts. So it doesn't say y-intercepts, but I need extra points. You can try your y-intercept. So I would get y equals, and you could either plug that y-intercept up here or into your standard form. It's easier in the top, because if I plug in a 0 here or 0 here, what do I get? 0 minus 0 plus 54. Are you going to want to graph 0, 54? No, heck no. Okay? So you're gonna need extra points anyways because you only have 2 right now. So if I started with my vertex 7, 5, and my x-intercept or my y-intercept was like way up here, okay, I can simply just plug in additional points like 6 and 8 into my equation, and I can plug them in either here or I can plug them in here to get my additional points. So I'm going to say if x equals 6, I would get y equals 6 minus 7 squared plus 5, negative 1 squared plus 5, 1 plus 5, which is 6. And if I did the same thing for 8, because this should be symmetric, I expect to get the same thing. So once I got that my y-intercept was like 0.54, like I don't want to graph that. So I just pick a point from left and right of my vertex and plug it in. So my vertex, my x was 7, right? So I took 6 and I took 8. I plugged it in. And you can either plug it into the original one or into your standard. It's usually easier into your standard. Like the y-intercept is easier in your original if it's in standard, if it's in quadratic. And then the other points are, I mean, you can choose, but instead of doing like a 6 squared minus a 14 times 6 plus 54, you can plug it in.
So you just pick the ones like left and right?
Yeah. You want to just make sure, I mean, the easiest thing to do is one from the left and one from the right. Questions on that process? All right. Now let's say this is my other option. So one option, if it's not in standard form, is that I force it into standard form using complete the square. The other option is follow this process. So I keep it in ax squared plus bx plus c form, and then I find the vertex by doing negative b over 2a for my h. So I take the sign that's on b, change it, put it over 2 times a. And then I take that and plug it back in plug h back into the equation to get the k. So you're basically finding f of h once you get h, okay? So negative b over 2a gives you h, and then take that, plug it back into your equation, and that's your k. And then everything else is the same after that. Your axis symmetry is x equals h. You can find your intercepts, keeping it in standard form, or sorry, keeping it in quadratic form. And then use your vertex and your intercepts or any additional points you need to plot the rest of your graph. So I'll say it again. On a quiz, if it says use complete the square to get it in a standard form, you're going to have to complete the square to get it in a standard form. But if it just said graph and it's in quadratic form, you could choose which way you want. Honestly, I look at it and I say, is there a number on front of x squared? If it is, it's not going to be fun to complete the square. I do it this way. If there's not a number on the front of the x squared, I tend to prefer complete the square. But how you do it is up to you at that point. You do have to know how to do both methods, though. All right, so we're just going to find the vertex. So my h is negative b over 2a. From this equation, what's my a? Negative 1. What's my b? Negative 3. So this is negative 3 over 2 times negative 1, which is positive 3 over negative 2. So the h is negative 3/2. And then I got to take that and plug it back into my equation to get the k. So y equals negative 3/2 squared minus 3 times negative 3/2 plus 7. square it first. So negative 3 halves squared is what? 9/4. Negative 3 times negative 3 halves is positive 9 halves plus 7. I can either multiply everything by 4, but then I have to divide by it at the end again. Or I can just change them so they all have 4 as their denominator. So negative 9/4. This would have to get multiplied by 2. So that's 18/4. This would have to get multiplied by 4. So that's 28/4. And then negative 9 plus 18 is 9. Plus 28 is 37/4. And that's the K or the Y coordinate of my vertex. You can leave it as 37/4 and negative 3.5. Just realize that when you go to graph it, obviously you need to make that a mixed number. That's going to be the same thing as negative 1 1/2 and 9 1/4, because eventually we're going to graph these, right? All right, I'm going to stop there. We're going to finish the notes tomorrow. Okay, I am going to open up your 2.1 homework so that if you want to start it tonight, not leave it all for tomorrow, I would advise at least starting it, okay? And then make sure you're ready to go for tomorrow. Make sure you have your calculators. Make sure you're ready to go for that part, the last part of your test. Yes?